In this video, I'm going to be talking about linear functions. We've talked about functions as a general concept, and now I want to hone in on a specific type of functions and the type that we're going to be dealing with for quite some time. So linear functions, the difference between a linear function and just a general function is that it's a function involving numbers. So I might even just do bullet points here. It's using numbers. We're talking about something being linear, then it has a number relation. And those numbers, the outputs have a constant difference. Meaning that if I go up 1 in x, every single time I go up, or 1 in my input, then I go up a certain amount. So maybe 2 in my output, or 2 in my input, I go up 4 in my output, right? It's constantly the same. Has a, maybe we could say that we have a constant rate of change. And rate of change is just, that's the change in my y, or my output, divided by the change in my input. So I'm throwing a lot of mathy things at you right now, but that's what a linear function is. It's a function that has a constant difference, a constant rate of change. So how can we picture this with just numbers? We're going to talk about 3 ways to identify linear functions. The first way is using tables. The second way, and that'll be the most maybe arithmetically intense, where we have to do some calculations. Second way is through functions, which generally is more of an eyeball test. Sorry, yeah, looking at equations, not functions. Looking at equations is kind of an eyeball test. And then the third way is looking at graphs, which is definitely an eyeball test. Okay, so a linear function, if I have a table, let's create a table of values, x and y. So again, generally I say x is my input or my domain, y is my output or my range. Okay, so let's say, and let's just do a really basic linear function, one that you'll see a lot. 1 and 2, 2 and 4, 3 and 6, and 4 and 8. Okay, now with this particular function, this particular linear function, and I guess, how can we tell that it's linear? I'm telling you that it's linear, but how can we tell that it's linear? Well, I want to see if my rate of change is constant. So the change in my output over the change in my input, does that stay the same? Let's look. What's the change in my output to go from 2 to 4? To go from 2 to 4, I add 2. And when my change in output was 2, what was my change in input? Well, to go from 1 and 2, I add 1. From 4 to 6, I add 2. From 2 to 3, I add 1. From 6 to 8, I add 2. From 3 to 4, I add 1. Okay, is that constant? Well, each time when I go up 1 in my input, you can see here, I'm going up 2 in my output. And you could do that 3 times. You could say, oh, well, I have plus 2 over plus 1, and then I have plus 2 over plus 1, and then I have plus 2 over plus 1, right? The change in my output over the change in my input is the same every time. And, well, we'll do another example in just a second, but that looks pretty good. Normally, I'd say reduce your fractions. So here, the rate of change is 2 each time, right? 2 over 1, change in output over change in input. So because that's constant, this is a linear function. Okay, let's look at another example with a table. Oops, want that? Sure. So another example with a table, and maybe you'll see it like this. This can work too, right? X and Y like this. 1 and let's do this. 2 and 7. 4 and 13. 5 and 16. And 8 and 25. Okay, so this is a little different than what we just looked at, but I think that's a good thing. Let's look at the rate of change. Again, X is my input, Y is my output. Up here, I have +2. When my input increases 2, my output increases 6. When my input increases 1, my output increases 3. And when my input increases 3, my output increases 9. So let's look at all of those, right? I have +6 over +2. I have +3 over +1. And I have +9 over +3. Now, are those all the same? Well, if by the same you meant do they have all the same numbers, then no, they're not the same. But are they the same value, right? Are they the same value? That's kind of a question I'm asking right now. Are these all the same value? Well, what's 6 divided by 2? That's 3. What's 3 divided by 1? +3. What's 9 divided by 3? 3. So each time I do have a constant rate of change, right? I'm increasing by different things each time, but my rate of change is still 3, right? 3 over 1. Every time my input goes up 1, my output goes up 3. And so that means when my input increases 2, my output increases 6. When my input increases 3, my output increases by 9. So this is also a linear function. Both of those are linear. Okay, maybe let's do one non-example. One example where it's not a function. I don't know, I guess I'm telling you that, so almost feels like cheating, but yeah. We'll do one more. If I had something like this, 1, 2, 3, and then I had, I don't know, 3. Ooh. So this one. Over here I have 1, 4, and 9. That's 1. Okay, some of you might recognize this pattern. Here, 1 to 2, that's +1. Here, that's +1. From 1 to 4, that's +3. From 4 to 9, that's +5. So when I'm increasing by 1, the first time I increase by 3, but the second time I increase by 5. So I don't have a constant rate of change, right? That's +3 over +1 and +5 over +1. So this one is not linear. Hope you can see that. That's not a linear function because it doesn't increase. Sorry, I put +5 there. I meant +1. +1, +5 over +1. It's not linear because it doesn't have a constant increase. Now, You might see, oh, well, this is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. That is a type of function. It is a function, but it's, and it's even, we call that a quadratic function, but it's not linear, okay?